Okay, we're looking at a problem of limiting reactants. Here I have some solid white phosphorus, P4, which is reacting with oxygen, 5 units of oxygen, 5 moles of oxygen, to produce P4O10, tetraphosphorus decaoxide. So I want to find, if I have this much P4, 25.0 grams, and 50 grams of oxygen, what mass of P4O10 would be formed. In order to do that, I have to find out which of these two numbers, 25 and 50, are the limiting reactants, because if I know that, then I can use that number to find how much PO4 is present. So we're going to first take these amounts and turn them into moles. So I'm going to take 25.0 grams of P4, and I'm going to turn it into moles. And so 1 mole of P4 is equal to the atomic mass of phosphorus times 4, which would be 123.9. A little bit of rounding here because I'm using the textbook answers. When we do it, we get 0.202 moles of P4. And I'm writing 3 significant digits because of my 25.0. I then take the 50 grams of oxygen, and I'm going to find out how many moles that is. Again, 1 mole on top, always 1 mole whenever I'm using atomic mass or molar mass. And because it's O2, it's 16 times 2, so 32.00 grams of O2. When I do that math, I get 1.56 moles of O2. So I have 2 groups of moles. What I want to do is take those 2 moles and put them into a ratio. So I'm going to take 1.56 moles of O2 and divide that by 0.202 moles of P4. I put the larger one on top. No, nothing special about that, just because it's easier to get a whole number. So I get 7.72 moles of O2 for every 1 mole of P4. Now that I have that ratio, I'm going to go back to my balanced formula, which is here, P4, 5O2, and look at what is the ratio between P4s and O2s here. Well, you see there's a 1 there, even though it's not present, and a 5 there. So I'm going to use that to put my ratio here. So 5 moles of O2 over 1 mole of P4. And now I'm going to compare these 2 numbers, the moles of O2. I need 5 in order for this reaction to happen, but I actually have 7. So therefore, my O2 is my excess reactant, and my P4 is my limiting. So therefore, this number is the number I'm going to use for all of my further stoichiometric conversions. So we're going to take that number, 0.202 moles of P4, and I want to find how many grams of P4O10. So set up my stoichiometry. 0.202 moles of P4. Since I'm already in moles, I don't need molar mass. I'm just going to use my ratio. So of course these go down here, moles of P4, and I want moles of P4O10 because that's what I'm going to. That's what I want to end up with. Look back at my initial reaction. I have got a 1 here, right? And 1 of P4. So therefore, it's a 1-to-1 ratio. I do go ahead and write it, even though it won't affect my calculations. I'll go ahead and put it in there. And now, I want to get from moles to grams. Moles of P4O10 in grams of P4O10. And of course, it's always 1 mole. I take 4 P's and 5 O's from my periodic table, and I get 283.9. When I do my multiplication here, I get 53.7 grams of P4O10. that I make in this reaction. So all of that was to answer this one question of what mass was produced of this, what mass is formed from that amount. I first took my grams and made them into moles, took my moles and made a ratio of them, compared this ratio to this ratio, which I got this again from my balanced equations. Find that this is my limiting reactant. Then take that limiting reactant moles and find grams of P4O10. The second part of this question asked us how much excess reactant remains after the reaction stops. So I want to know from this 50 grams of oxygen, which remember we said that P4 is my limiting reactant, so oxygen is my excess. Of that 50 grams, how much is left over? So you might think, well, let's just start with this 50 grams right here. But no, because that's too much. We don't know how much of that's going to be used. We do know that all of my 25 grams of P4 is going to be used. So we're going to use that number. We're going to use the same number we started with here, this 0.202 moles, and make that happen. So 0.202 moles of P4, we're going to change that into my excess reactant. Again, my excess reactant was the O2. So moles of P4, moles of O2 go to my formula. And I see that I have a 5-to-1 ratio. So 5-to-1. I then change my moles, right? Because of course units always come down. Always come down. Moles of O2 into grams of O2. 1 mole, and the molar mass of oxygen is 16 times 2, so 32.00. I put it in, and I end up with 32.3 grams of O2. This is how much I would use. I used this much, 32.3 grams. But of course, I started with 50 grams, and I want to subtract then that 32.3 grams, and that will give me a final answer of 17.7 grams of O2. That is how much excess remains after I am done. Again, feel free to use 11.3, the limiting reactant section. This is straight out of example problem number 5, as well as the notes on Schoology.